All right, trigonometry day 1. We're just going to do a review of Sohcahtoa and Pythagorean Theorem. So it's a one-day quick review. All right, so if angle AOB is shown, and we're going to call it X, each side of the triangle is given a special name relative to that angle. So remember, opposite the right angle is the longest side, and that's hypotenuse. Opposite of our special angle, or the angle it's given or that we're looking for, is the opposite side, and then the one between the 90 and your angle is the adjacent, which means beside. So between the 90 and your angle. So those are the sides. So each one, we have three special ratios. If you have three different sides, there's three different ratios. We could either compare the opposite with the hypotenuse, or we can compare opposite with adjacent, or hypotenuse with adjacent. So there's three different ways we can compare those sides. All right, so if there's three, and because of that, then we have three different ratios. So remember Sohcahtoa. We could also write it like this, Sohcahtoa. Now, most of this unit, we're not going to be using Sohcahtoa. In fact, we're going to stay away from it entirely. Why? Because it only works for right-angled triangles. It has to be a right triangle. And most of the triangles we're going to deal with in this unit will not be right triangles. So your entire unit exam won't actually have Sohcahtoa. None of it. Zero. We're going to do a review because it's going to lead to the new theorems and how we prove those theorems. So we have to start with a review of right triangles. So mark on each triangle the hypotenuse, the opposite, and the adjacent. So if this is my x, remember opposite the right angle is the hypotenuse. Opposite our angle is the opposite side. And then the adjacent side is the other one, between the 90 and your angle. So again, usually what I would start with is, given that first angle, mark the opposite first. So it's opposite the angle, and then do your hypotenuse, which is opposite the right angle. Hypotenuse, and then the last is adjacent. And so that's only for when we have a right triangle. So let's complete these ratios. Sohcahtoa. Okay, so sine of x, opposite over hypotenuse. So here's x. Our opposite is side DE. Over our hypotenuse is going to be side FE. Cos is adjacent divided by hypotenuse. So adjacent is side DF. And hypotenuse is DE. Oh, that doesn't seem right. Hypotenuse is FE. Let's change that. Okay. Tan is opposite side, so our opposite side divided by the adjacent side. So adjacent and opposite. So opposite is DE divided by adjacent, DF. Okay. Sine of y. So again, sine is opposite divided by hypotenuse. So opposite side is side VS. Hypotenuse is side VT. Cos would be your adjacent of ST divided by hypotenuse VT. And tan of y is opposite VS over adjacent ST. So just a review, here's all the different ratios, and of course Pythagorean theorem. If you're looking for, say you're given C and B and you're looking for A, how do we do that? Well, A squared would be our hypotenuse minus the other side squared. Okay, so all of this you should know. So let's look at an example. It says use Pythagorean theorem to calculate ST. So the first thing is we label the hypotenuse, and so our hypotenuse is 25. That's the most important one. The other ones don't matter, so we can call this guy B for base and A for altitude. So how do we find Pythagorean theorem? Well, A squared is C squared minus B squared, and we use that when we know our hypotenuse. We can even simplify that to, we're going to have to square root both sides, so C squared minus B squared, and then the square root of that. If you want, we could just plug it in. So A squared is equal to 25 squared minus 7 squared. We grab our calculators and type that in. 25 squared minus 7 squared gives us 576. Except for we're not looking for a squared, we're looking for a. So what's the opposite operation of squaring? Is square rooting. So we square root both sides. So with your calculator, second x squared, second negative. Bring up your previous answer, and a is 24. So our a, or side, I'm going to erase this, our side st is 24. Okay, so state all the rational numbers, or all the ratios. So what is sine of r? So again, Sohcahtoa. So we need to start with r. We'll do all the r's first. Let's label everything based on angle r. So start by labeling your opposite side, hypotenuse, and then adjacent. So sine of r is O over H. O over H, so 24 over 25. Cos of r would then be adjacent over hypotenuse, so 7 over 25. And tan of r is opposite divided by adjacent, so 24 over 7. Okay. Now, if we're working with angle S, then our side labels change, right? Now our opposite is 7, and our adjacent is 24. Hypotenuse doesn't change. So sine, which is opposite over hypotenuse, becomes opposite of 7 over hypotenuse of 25. Cos of S, which is adjacent over hypotenuse, is 24 over 25. And our tan, which is opposite over adjacent, opposite is 7 over adjacent of 24. Okay? So what relationships do we see? Do you notice that the relationship cos of r is equal to the sine of s, and the sine of, the sine of r is equal to the cos of r, cos of s. There we go. So sine of r is equal to the cos of s, and the sine of cos of r is equal to the sine of s. Sine of r is equal to the cos of s. Okay? And then the tan ratios are just the reciprocal of each other. And then tan ratios are reciprocal, or flipped, right, of each other, reciprocal. Okay, so let's look at some problems, go through some other stuff. So how do we solve when we're looking for the angle if we have our ratio? So if you're given a special angle, we still have to label our sides. So first label opposite, we have our hypotenuse, and then adjacent. Which side do we not know and don't need? Remember, you always need two things to find a third, and always one of those things must be a side. So we know two sides, and I want to find an angle. We don't need hypotenuse because we don't know it. So how do we do that? Well, that's when we use inverse. Remember second tan or inverse tan? So how we set this up is we figure out our ratio. Because we need O and A, we need tan, opposite over adjacent. We fill in what we know. Tan of x is equal to opposite of 6 over adjacent of 5. And last, if you want to move the tan to the other side, we actually have to use inverse tan. Inverse tan is the opposite of tan. And so in your calculator, you have to go second tan. Let's review that your calculator must be in degree mode. So if you go to mode, down arrow twice, one arrow to the right, and push enter, you have to be in degree mode. Remember how we check that. Tan 45 should always equal 1. So whenever we're looking for an angle, that's when we use inverse tan. Second tan of our ratio, which is 50.2 to the nearest degree is 50 degrees, would be our angle. Okay? And so that's just a review from last year. So let's look at an example. A telephone pole is 12 meters high. It is supported by a wire. Okay, so there's a wire. Remember, all of these are right triangles. And the wire is 14 meters long, fixed to the top of the pole and to the ground. Draw a sketch and then calculate to the nearest degree the angle between the wire and the ground, which is also called our angle of elevation. Okay, so we start by drawing our triangle, then we label our sides. So first, opposite, hypotenuse, and I don't even need to label adjacent because they don't give it to us. Which ratio do we need? So we use Sohcahtoa. We ask ourselves which ratio has O and H? That's sine. So we're going to use the sine ratio. So you write out the formula. Sine of your angle equals opposite over hypotenuse. Sine of, do we know our angle? No. Equals opposite of 12 over hypotenuse of 14. And how do we get our angle? When we have our ratio, we have to move the sine to the other side. How do we do that? Inverse sine of our ratio gives our angle. So with your calculator, second sine of 12 over 14. And change that to a decimal beforehand if you want. Or just type it in like that. To the nearest degree, it is 59 degrees. So 59 degrees. Okay. So how do we find a side for given an angle? Okay, so here is an example where we're looking for our opposite side and we have our hypotenuse. So again, you ask yourself, which ratio do I use? And the ratio would be sine because we have our hypotenuse and we want to find our opposite side. So we have the formula, we plug it in. Sine of our angle, 49, equals opposite of x over hypotenuse, 17.6. Then we want x by itself, so we multiply both sides by 17.6, and then we get x by itself. So plugging it into your calculator, 17.6 sine of our angle gives you to the nearest 10th, 13.3. So our side BC is 13.3. Okay. What if x is on the denominator? So I'm given this is 73. So again, we label our sides. We have opposite, adjacent, hypotenuse. Which side don't we need? I'm not looking for opposite. I'm looking for adjacent. So we want the ratio with A and H. So Sohcahtoa. A and H is our cosine ratio. So you start by writing out the formula. You should always actually write your formula. So that's missing. Cos of our angle equals A over H. And then we sub. Cos of 73 degrees, adjacent is 24, hypotenuse is A. Okay, so how do we solve? Well, we want to get A on the numerator because we can't solve for it when it's on the denominator. Our first step is to multiply both sides by A. So we have A times cos 73 equals 24. And then divide both sides by cos 73. And so 24 divided by cos 73 is going to be our side. And that's going to be 82.1. 82.1. 82.1. Let's try one on our own. Use trig ratios to determine the length of AB and AC. So who do you want to solve for first? Let's solve for AB, my opposite. Okay? My opposite, we can call that x if you like. And let's label everything. Opposite, hypotenuse is over here. Adjacent is the 109. If I'm looking for my opposite and I have my adjacent, which ratio do I want to work with? 10. So we write out our formula. Tan of our angle equals opposite over adjacent. And sub in what we know. Tan of, which angle did we work with? 74. Our opposite side was x over adjacent, which was 109. X is on the numerator, so we're going to multiply both sides by 109. Now we have x by itself. So with your calculator, 109 times tan 74. The nearest foot, it says, is 380 feet. Equals x. Now we're not done, so we just replace this. Our opposite side is 380 feet. You could use tan ratios again, or if we know two sides, how could we get a third? Pythagoras. c squared equals a squared plus b squared. And we're looking for our hypotenuse, which is our c. So c squared is equal to 109 squared plus, we should technically use the exact value they gave us, right? That exact value of 380.128, so forth. So in your calculator, let's use the exact. And so let's plug this in. So 180 squared, or 109 squared, don't know where 180 came from. 109 squared plus second negatives my previous answer squared, gives me that, and then we're going to square root that. And so the nearest foot is 395. So c equals 395 feet. And so I should probably say AB. Which one was AB? AB was the 308 feet, and AC was the 395 feet. And there is our final answer. Okay, one more example and then we're done this lesson. A large tree is to be transported to a new location. The tree is held vertically by means of two guy wires of unequal lengths on opposite sides of the tree. One of the wires make an angle of 48 with the ground. The other wire is 12 meters long and makes an angle of 56 with the ground. Both wires are attached 3 meters down from the top of the tree. So they're both here, attached there. And then we're going to attach them to the ground. One, make a better line. One, try something. Oops, sorry. So one's here, one's here. Okay? And they're both 3 feet, I believe it was 3 meters, down from the tree. So it's a really big tree. 3 meters is pretty tall. Okay? Now let's draw this out again. So here's the center of our tree. And one wire makes, so one of them is 48 degrees with the ground, and the other one's 56. So 48 degrees from the ground. The other makes an angle of, it's a 12 long wire, it makes a 56 degrees. Okay, and the one with 56 is, okay, this is 12 meters. This part of the wire is 12 meters. This is what they gave us. Determine the height of the tree to one decimal place. So we're looking for, if we know this part here, we can add 3 to it, and we'll get the total height of the tree. So which triangle do we want to work with? Well, the one on the right, we only know an angle. The one on the left, I know an angle and a side. So that's the one we want to work with. So with 56 degrees, we have our opposite and our hypotenuse. So that would be the sine ratio. So sine of our angle equals over h. So plugging it in, I have sine 56 equals opposite of x over hypotenuse of 12. I want to get x by itself. It's being divided by 12. So we're going to multiply both sides by 12. Plugging that in, we have 12 times sine 56. And that's 9.948. 9.948. I don't want to necessarily round just yet. Meters equals x. And so what's the total height of the tree? Well, we need to add that 3 to it. So that would be 12.9 to the nearest 10th meters is the tree height. 12.9 meters. Okay, so we know that this x here now, it's 9.9. 9.9. Okay, it says determine the length of the wire to the nearest tenth of a meter, the other wire. So we need this wire here. Maybe I'll call that y. So we already used x. So with this triangle now, we now know our opposite, and we're looking for our hypotenuse. So again, we're going to use sine. The sine is over h, sine of our angle. Sine of 48 degrees is going to equal to our opposite of 9.9 over hypotenuse of y, not x. We need y in the numerator. So our first step is always, when we're solving for a side, to multiply both sides by whatever's on the bottom there. In this case, it's y. So we have y sine 48 degrees equals 9.9, and then divide both sides by sine 48. Okay, so in my calculator, luckily I still have the 9.9 there, so I can just go divided by sine 48, because we want to use our exact values. And to the nearest tenth, that's 13.4 meters long. So the wire is 13.4 meters long. Okay. Now it says, now determine to the nearest tenth of a meter the horizontal distance on the ground level between the two wires. So I'm just going to replace this y here with 13.4. Okay. So now they want our whole length between the wires, so A and B. Okay, so in the first triangle, I'm looking now for my adjacent with the sine 56. I want that A, and I know my opposite, I know my hypotenuse. I'm going to use my hypotenuse because that's a given value instead of a calculated value. So we know adjacent and we know hypotenuse, we want adjacent. That's going to be cosine. So cos of our angle is A over H. We're using the very first triangle here. Cos of 56 degrees equals our adjacent, we'll just call it A, over hypotenuse of 12. And then multiply both sides by 12. So our A value is 12 cos 56, 6.7. 6.7 meters equals A. And now we got to do the same thing with B. So B, I have to use my opposite and my hypotenuse because we don't know B. Oh, sorry. We want B, which is our adjacent. And we have our hypotenuse or our opposite. So it's really up to us. They're both calculated, so let's use tan, opposite over adjacent. Tan of our angle is opposite over adjacent. Tan of 48, our opposite we calculated to be 9.9 over our adjacent is now the letter B. So multiply both sides by B. Got to get B on the numerator. We get B tan 48 equals 9.9, and then divide both sides by tan 48. Really, we're solving everything there is to know about this triangle here, hey? We know it all after we're done. So B is equal to 9.9, which is actually 9.948450. So you should use our exact values. 871 divided by tan of 48 gives me, well, how is that going to change our rounding to 9.0, right? 9.0. And so our total distance, we got to add A plus B together. So again, we should be using our exact values here. So I'm going to go just my previous answer plus the 6.7103144842, and we have to the nearest tenth is 15.7. 15.7 meters is the length between the two wires. Okay, so it says, and last, the guy wire in C breaks. The wire breaks, and a new wire of the same length is attached 2 meters down from the top of the tree. Calculate to the nearest degree the angle which the guy wire makes with the ground. So now what happens is that instead, here's our tree, it's going to be attached 2 meters down. Right? And so that's going to change our angle. We're going to use the same wire. So how long was that wire that we calculated here on this side? We calculated the wire to be 13. So initially it was farther away. But we're going to attach it higher and make it a little tighter. Okay, so now it's 2 meters below the tree. So how tall is our tree? We calculated this, right? Our length of our tree is 12.9. 12.9 meters. So now if we attach it 2 meters down, how much is this length here? Well, minus 2 is 10.9 meters. So the bottom half is 10.9, and now we're looking for this new angle here. So it used to be 48. What's the new angle? Okay, we have two sides of our right triangle. Here's opposite and hypotenuse. We're going to use sine. Sine of our angle equals opposite over hypotenuse. So sine of angle x equals 10.9 over 13.4. And how do we get our angle by itself? We use inverse sine of our ratio. So grabbing our calculators, second sine, and we're going to the nearest degree. It's better if I use my exact values here, but I'm just going to use these. And the nearest degree is 54 degrees. So that 48 becomes now a 54. It was attached 2 meters down instead. All right, that's it for this lesson.